3418. Crests of standing mountain waves may be marked by stationary, lens-shaped clouds known as A. Cumulus clouds. B. Standing lenticular clouds. C. Roll clouds. The correct answer is B. When stable air flows over mountains, it can create a wave pattern in the atmosphere. The crest of these standing mountain waves can be marked by stationary, lens-shaped clouds called standing lenticular clouds. These clouds form as moist air flows over the mountains and condenses at the crest of the wave, creating the distinct lenticular shape. The clouds remain stationary or nearly stationary, indicating the presence of the mountain wave. Standing lenticular clouds are often seen in mountainous areas and can be a visual indicator of atmospheric wave patterns and potential turbulence in the area. 3420. What cloud types would indicate convective turbulence? A. Cirrus clouds. B. Nimbostratus clouds. C. Towering cumulus clouds. The correct answer is C. Towering cumulus clouds, also known as cumulus congestus clouds, are large, puffy clouds with vertical development. These clouds are often associated with convective turbulence, as they indicate the presence of strong updrafts and vigorous vertical motion within the atmosphere. The rapid upward movement of air can lead to turbulent conditions, including strong updrafts and downdrafts, which can be challenging for aircraft to navigate. Pilots should exercise caution when encountering towering cumulus clouds, as they can be indicative of turbulent weather conditions and potential thunderstorm development. 3425. Possible mountain wave turbulence could be anticipated when winds of 40 knots or greater blow. A. Across a mountain ridge, and the air is stable. B. Down a mountain valley, and the air is unstable. C. Parallel to a mountain peak, and the air is stable. The correct answer is A. When strong winds with speeds of 40 knots or higher blow across a mountain or ridge, and the air in the surrounding area is stable, it is important to anticipate the possibility of mountain wave turbulence. Mountain wave turbulence occurs as the strong winds encounter the mountain or ridge and are forced to rise, creating waves of alternating updrafts and downdrafts in the air. This type of turbulence can pose a significant risk to aviation because it can cause sudden and severe changes in aircraft altitude and airspeed. The updrafts and downdrafts associated with mountain waves can result in vertical accelerations and variations in lift, making the aircraft more difficult to control and potentially leading to loss of control if not properly anticipated and managed. To mitigate the risks associated with mountain wave turbulence, pilots should be aware of the current wind conditions, especially when strong winds are blowing across mountainous terrain. Monitoring weather reports, including wind speeds and directions, can help pilots anticipate the potential for mountain wave turbulence. It is also important to maintain good situational awareness and be prepared to adjust the flight path or altitude to avoid areas of known or anticipated turbulence. Furthermore, pilots should adhere to recommended turbulence penetration speeds and techniques when flying in mountainous areas with strong winds. These guidelines help minimize the effects of turbulence on the aircraft and ensure the safety of both the aircraft and occupants. In summary, anticipating the possibility of mountain wave turbulence in situations where strong winds of 40 knots or greater blow across mountains or ridges and the air is stable is crucial for safe aviation operations. By being aware of these conditions and taking appropriate precautions, pilots can better prepare for and mitigate the potential risks associated with mountain wave turbulence. 2159. One of the most dangerous features of mountain waves is the turbulent areas in and A. Below rotor clouds. B. Above rotor clouds. C. Below lenticular clouds. The correct answer is A. One of the most dangerous features of mountain waves is the turbulent areas that can be found below rotor clouds. Mountain waves occur when strong winds encounter a mountain or ridge, causing the air to flow over the obstacle and create waves in the atmosphere. Within these waves, rotor clouds can form, which are ventricular-shaped clouds that indicate the presence of strong turbulence. The turbulent areas below rotor clouds can be hazardous for aircraft flying in mountainous regions. The turbulent airflow within these areas can be unpredictable and turbulent, posing a risk to aircraft stability and control. Pilots should exercise caution and avoid flying in or near rotor clouds to minimize the risk of encountering severe turbulence. 3442. Upon encountering severe turbulence, which flight condition should the pilot attempt to maintain? A. Constant altitude and airspeed. B. Constant angle of attack. C. Level flight attitude. The correct answer is C. When encountering severe turbulence, the pilot should attempt to maintain a level flight attitude. This means keeping the wings level and the nose of the aircraft at a constant pitch attitude. By doing so, the pilot can minimize the effects of turbulence on the aircraft and provide a more stable and controlled flight. Maintaining a level flight attitude helps to distribute the forces of turbulence evenly across the aircraft, reducing the likelihood of sudden altitude or airspeed changes. It also allows the pilot to have better control and situational awareness, making it easier to assess the situation and make appropriate adjustments if necessary. While it is important to maintain a constant altitude and airspeed as much as possible, the primary focus should be on maintaining a level flight attitude to ensure the safety and stability of the aircraft in severe turbulence conditions.